Welcome back, guys. In this video, we're going to be solving this very problem or set of problems. Now, notice that these two are actually the same. The only difference is the constant multiple pi over 2 with the second one. So let's solve the first one. Now, I've kind of done something similar to this in the previous video. So let me just do this one. Okay, I think this should be like pi over 32 or something. So for the first one, we have the integral from 0 to 1. X to the 4. Now, to start with, there's a better way of writing this. 1 minus x squared. This can just be written as 1 minus s squared all raised to the power of half because of the square root. This square root will give it the power of half, dx. So that's what I have, right? Yeah, that's what I have. Now, also, I could make this much more interesting. If this is s squared, and I have it in mind that I'm going to be substituting, I'm going to say let u become s squared. I could say that this very x here, let me write this s squared times 2. Yeah, I could do it like that because s to the power of 4 is x squared times s squared. So I can double it to make life easy for me. Now let's start. Let u become s squared. Let u become s squared. Now this means that if I want to remove this squared, I need to square root the other side. So the square root of u is equal to x. However, this very square root means the power of half. So u to the power of half is actually x. Now, one more thing is left, our derivative. Because this is with respect to x, we're changing to u, so every other thing has to change to u. So if u is equal to s squared, this means that du is equal to x dx. Because when you differentiate s squared, you're going to have 2x. And then you're going to put your dx. Now, to make your dx stand alone, you must divide both sides by 2x. So this will be du divided by 2x. And this is equal to dx. But remember, since you are substituting, this x should not be here. This x should not be, every single thing on this side should be u. So this x should not be here. So this is du divided by 2x. What's the value of x? S is u to the power of half. And this is equal to dx. Now we can try to solve our integral now. So this is our integral. So our integral I is equal to 0, okay, integral from 0 to 1. X squared, I kind of wrote it in a better way. S squared squared. And then 1 minus s squared, so the 1 over 2 dx. Like I said, it's just still the same thing. So this is equal to integral from 0 to 1. And this s squared, what is s squared? U is equal to s squared. So this will be u. Then don't forget that there's a squared outside. That's u squared. And then 1 minus, this is s squared again. So what would this be? U. So still be u. And then to the power of half. Now, what is dx? Dx is du over 2u to the power of half. So this is du divided by 2u to the power of half. It's kind of sweet. So let the over 2. This is 1 over 2. Let it come outside. So that's going to become 1 over 2 integral from 0 to 1 of u squared. This is division, right? So I want to put the division here. Let the division come here to the power of half. Then I have 1 minus u to the power of half. And then du. Yeah, let it just be like that. Now this will be 1 over 2 integral from 0 to 1. Since I'm dividing two items with same base, I can subtract the powers. So this is u to the power of 2 minus half. Then 1 minus u to the power of half du. Now this is half integral from 0 to 1 u. Now what is 2 minus half? 2 minus half is 3 over 2. So this is 3 over 2. And then 1 minus u to the power of 1 over 2 du. That's what you're going to be having. So that's kind of, easy in a way. It is easy. Okay. Now what we're going to do next is, this will be 1 over 2 beta of, if this is 3 over 2, this will be 5 over 2 here, comma. If this is 1 over 2, this will be 3 over 2. Now, how did I get that? Remember that from the standard form, if this is m minus 1, to get the value of m, you need to add 1. So if this is 3 over 2, when you add 1 to 3 over 2, you can work it out. 3 over 2 plus 1 will give you 5 over 2. Then 1 over 2 plus 1 will give you 3 over 2. That was how I got that. Now this will equal to 1 over 2 beta. Okay, no, I want to write it in terms of gamma now. So this will be the gamma of 5 over 2 times gamma of 3 over 2 divided by the gamma of 5 over 2 plus 3 over 2. Okay, so that's what we're going to be having. Now this will equal to 1 over 2 times, now remember that I said something. This is actually easy to do. The gamma of 5 over 2, what is 5 over 2 minus 1? That's 3 over 2. This is 3 over 2 times, what is 3 over 2 minus 1? That's 1 over 2. And then gamma of 1 over 2. That's gamma of 1 over 2. And then times, this gamma of 3 over 2. So what's 3 over 2 minus 1? That's 1 over 2. Gamma 1 over 2. Once you get to 1 over 2, just put gamma 1 over 2 beside it. And then divided by, now 5 over 2 plus 3 over 2 is 4. Because 5 plus 3 is 8. 8 over 2 is 4. So what is the gamma of 4? Gamma of 4 is 3 factorial. Gamma of 4, you're going to say 4 minus 1. So that's 3 factorial. Okay, let's see. So this will become 1 over 2 times, for the top, let's times all of the top terms. 3 times 1 times 1, that's 3. Over 2 times 2 times 2, that's 8. Now the gamma of half and the gamma of half. Gamma of half on a normal day, that's just root pi. So this will be root pi times root pi, because we have the gamma of half appearing twice. Divided by 3 factorial is 6, or you could say 3 times 2 times 1. It's actually your choice. So that's just what it's going to be. Now this is 1 over 2 times, now the top remains 3, root pi times root pi is just pi. Divided by, this over 8 will come down. The over 8 comes down. So this becomes 8 times 3 times 2 times 1. Now that's how fraction work. So this over 8 will come down to meet this other this other division sign here. Now 3 we cancel out 3. So what's going to be left? This is pi over 2 times 8 is 16. 16 times 2 is 32. So that's pi over 32. Yeah, that's pi over 32. So that's what we have as the answer to the first integral. But remember I said that the first integral and the second integral, they are not actually different. So let's do the second integral. So the second integral says integral from 0 to 1 of pi over 2 x to the 4 root 1 minus s squared dx. Now I could write this as pi over 2, since it's a constant, integral from 0 to 1 x to the 4 integral of 1 minus s squared dx. Now we'll solve for this part. And the answer we had for this part is pi over 32. So this is pi over 2, the constant, times the answer we had for this part was pi over 32. So pi times pi, that's pi squared. 2 times 32, that's 64. And that will be the answer to that very equation. And this is the answer to every question on this board. So remember to hit the subscribe button, like this video, and share it across to your classmates. I'll see you in the next one.